Hey guys, welcome to another video for trig or pre-calculus, working out trig problems. I'm going to work out problems from 5.3 where we'll be solving trigonometric functions. Alright, so let's go ahead and dive in. I'm going to be going from 1 to I believe 9, and I'm doing all the odds to this point. And then class, you'll work out the evens, so let's go ahead and jump in. Alright, so number 1 says 5 sine x plus 2 equals sine x. And so again, in these problems we're solving. So we're looking for the value of x here. And let's see, where would I start off here? So I want to get rid of this sine x on this side. Okay, so that's going to leave me with 4 sine x plus 2 and then equals 0 on the right side. Now, sometimes I have students express concern with the fact that I have a 0 on one side of the equation, and that's okay. That's not a problem. So don't be afraid to leave a 0 on one side of the equation, because as you can see, I'll end up with something there anyways. So my next step here would be to subtract 2 from both sides, leaving me with 4 sine x equals negative 2. And then I can divide by 4 to get rid of that 4, and now I'm left with sine x equals negative 1 over 2. So now the next thing I want to do is I want to know the exact location of sine where sine x is negative 2. And you have to consider the fact that an entire period of sine x is 2 pi. It's always going to be 2 pi. Now that's going to be the same with sine x and cosine x. Always going to be 2 pi. So that's going to let you know that my interval will always be 2 pi times n, however many times I want to go around. I can go around a billion times, 3 times, 4 times, whatever the case may be. But it's always going to be on the interval of 2 pi n. So whatever my answer is, whatever my radian is that I get, I'm going to have to add 2 pi n. So again, my question at this point is, where will I find sine of x to be negative 1? Now consider the fact that sine of x equals y. When I'm thinking about the coordinate points, sine is always the y term. So if my y is negative, then that means that my answers are going to be on this side of my coordinate point. So where on my coordinate point, on my unit circle, is sine of x a negative half? And as you can see there, it's going to be negative half at 7 pi over 6 and also at 11 pi over 6. And that's essentially my answer. Now, recall that I have to add, because my answer can be 7 pi over 6, and it can also be 7 pi over 6 plus 2 pi. And then I can keep going. The n represents a variable, meaning I can go around as many times as I want, but I have to keep landing on 7 pi over 6 as my reference angle. And then the same thing with my other one. It's 11 pi over 6 plus 2n, my interval of 2 pi n. So that's my answer. Okay, so again, 7 pi over 6. This is where, if I write my coordinate points are negative pi 3 over 2 and negative 1/2. And the same thing over here with 11 pi over 6. My coordinate points for that is positive 3 over 2 because my x is positive. Now I'm on the positive side of the x, my coordinate grid. And then my y is negative half. And this is the part that led me to this point right here, is the fact that this is a negative half. So moving on with number 3, we have 2 minus 4 cosine squared x plus 1. So I want to isolate cosine x, so I want to move everything that's attached to it over to the left side. And let me highlight everything that I want to move. All of these terms here I need to get rid of. So I'm going to start from the outermost, work my way in. So I'm going to end up subtracting by 1 so subtract by 1, and then I'll also divide by 4, so divide that by 4, and then I'll end up square rooting that result also. So let's see how that works out. All right, so let me work it out step by step, because what I just did might be a bit confusing. So minus 1 leaves me with 1 over 4 cosine squared x divided by 4. So I'm left with 1 over 4 equals cosine squared x. And then, of course, I'm going to square root, and that gives me a plus minus. So it's plus minus 1 over 2 equals cosine x. And that's my result. Now, now I need to find the interval at which my solutions are going to be found at. And something interesting here is that the fact that this is a plus minus, and because it's a plus minus, that means that I need to find the area where, or the radians where the x term is positive and negative. So that essentially puts the entire, that makes the entire coordinate, my entire coordinate grid up for grabs. So let's see, where is cosine x positive and negative? So I see that it's positive at pi over 3. So let me write that here. It's pi over 3. It's also negative at 2 pi over 3. 2 pi over 3. And then also it's negative at 4 pi over 3. And then positive at 5 pi over 3. So these are all the locations where cosine x is half. Just as an example, let me highlight the coordinate points at pi over 3 so you can see how that works. So this is going to be positive half, and then the y term is square root of 3 over 2. Okay, and that's kind of how it plays out on the unit circle. So you can see here on the right side of how the coordinate points for those. So now, so pi over 3 is an example of one of my answers. But I can also use that as a reference angle and go a complete 360 or plus 2 pi, and then I can do that as many times as I wish. And because I can do that as many times as I wish, I'm going to signify that with the term n. And that's the answer for all of these. It's so 2 pi over 3 plus 2 pi n, and 4 pi over 3 plus 2 pi n, and so on and so forth. Okay, so that's my answer for number 3, my possible answers for number 3. So let's now work over to 5. 5 reads 9 plus cotangent squared x equals 12. So I'm going to subtract by 9. Again, I'm isolating cotangent. So that leaves me with cotangent squared x equals 3. And then I'm going to square root. So that means cotangent x equals plus minus square root of 3. And that is my result there. So now I need to find where, now recall that cotangent is actually cosine theta over sine theta. So I need to find the combination of coordinate points that when I multiply these out, I'm going to end up with a square root of 3. Now, since, it's a little trick that I use, since the square root of 3 is in the numerator and it's as a whole number, that means that my cosine has to have square root of 3 in it. And it can be positive or negative. We have that advantage. So it doesn't matter if I look on, I can look anywhere in the coordinate, in my coordinate plane to find square root of 3. And I see that pi over, let's see, where x, my cosine is x, or pi over 3. Where could I find that? That is pi over 6. So here, let me write that out, it'd be easier. Pi over 6 gives me square root of 3 over 2, and then my y is 1 over 2. And I can already tell this is going to work out because of the 2's are going to cancel each other out. So going back to this idea here, let me work this out down here. So cosine is pi over 3 over 2 divided by my sine, which is 1/2. And I want to move this over to the numerator, so that means I'm going to have to do the reciprocal. Square root of 3 over 2 times 2 over 1 gives me square root of 3 over 2. So that means pi over 6. That's the key. That's what I want. My intervals are pi over 6. So, and the good thing here is that it can be plus or minus. It can be plus or minus. So let's see here. Now, actually, something to consider. It can be plus or minus, but that does not, unlike cosine and sine, if it was plus or minus, that would leave the entire, let me clean this up a little bit so we can, let's have a clean workspace. That would give me the entire unit circle. But this isn't sine or cosine, this is cotangent. And if you recall, with tangent and cotangent, there are asymptotes. And those periods are not 2 pi. They do not go through 2 pi. Their periods are in intervals of pi. So anytime you have a cotangent or a tangent as an answer, your answer will have an interval of pi n. Unlike cosine and sine, they had intervals of pi n, 2 pi n. Okay, so I hope that made sense. Okay, so cotangent, that means, for example, if my answer here is pi over 6, then I can do plus pi times n. All right, and let's see, that's not the only one because I can do plus minus, so that means that my other interval here was 5 pi over 6. And of course, if that's my answer, then I have to put the full notation because I can also do plus pi times n. And that's my answer for number 5. Okay, now number 7. 7 is 3 cosecant x equals 2 cosecant plus square root of 2. So I want to simplify this to find out what cosecant is. And it looks like I'm going to find that out pretty quick. Cosecant x. It's going to give me cosecant x equals pi over 2. All right. Now recall that cosecant is 1 over sine x. And since this is sine x, I know that my answer, whatever my answer is, whatever radian this is, it's going to be plus 2 pi n. So I can get that right out of the way right now. So as I'm looking at my unit circle, I want to know which term has 2 pi. Where is 2 pi, or I'm sorry, square root of 2 in my y? And there's only one, and that's pi over 4. Pi over 4 has my y, my sine, where 2 pi is there. And in fact, my x is also square root of 2 pi. So let's work this out. So my answer is 1 over sine x, because it's cosecant. So 1 over square root of 2 over 2. And of course, as you know, I want to move this to the numerator, so I'm going to flip it. So that's going to give me the reciprocal of 2 times square root of 2. And I have a square root in the denominator, so I want to get rid of that. So I'm going to multiply by 1, right? So that'll give me, in the numerator, that'll give me 2 times square root of 2. And then square root of 2 times square root of 2 is 2. And I want to simplify this, so these two cancel out, and that leaves me with an answer of square root of 2, which is exactly what I have here. So that means this is my answer. My answer is pi over 4. So pi over 4 plus 2 pi n. Now, one thing also is that my y is positive, so that means that all the terms in quadrant 1 and 2 are up for grabs. So what other radian has square root of 2? Well, that's going to be 3 pi over 4. That will also give me the answer that I'm looking for. And of course, that's also going to be 2 pi times n. All right, so let's look at 2 more problems. Number 9, we have 6 tangent squared x minus 2 equals 4. So yeah, let's do this. So we're going to do a plus 2. Plus 2, that gives me 6 tangent squared x equals 6. Divide by 6, divide by 6. Tangent squared x equals 1, leaving me with tangent x equals plus minus the square root of 1. So recall that tangent x is sine x over cosine x, and this is going to end up equaling 1. So that means I want my two terms to be the same. And as I look at my unit circle, and this is a plus minus 2. This is a plus minus, so that means I can look at either side of my my unit circle. With the exception, recall that my period for tangent is 0 to pi. So I can't look anything below where y is negative. So that means there's only two places I can really look, and that is pi over 4, because at pi over 4, as you can see there on my graph, it's square root of 2 over 2 and square root of 2 over 2. So if sine x is square root of 2 over 2, and cosine is square root of 2 over 2, and I move this to the numerator, I end up with square root of 2 over 2 times 2 times over square root of 2 over square root of 2. I hope that came out right. All right, well, either way, as you can see here, this cancels out, that cancels out, that cancels out, giving me a 1, which matches what I have here. So, and again, this is a plus minus, so that means my other possible answer, my other possible solution is found at 3 pi over 4. And that's not the only place. It's also found at plus pi n, and that goes for this one as well. Right? So I know I'm moving kind of fast with these, but do recall that you can fast forward and you can ask questions in class, or you can slow it down and pause and what have you, so you can see what my steps are for each of these. So let me go ahead and finish up with number 11. 7 cotangent x minus square root of 3 equals 4 cotangent x. Right off the bat, I can see it's cotangent, so that means that my interval is going to be 0 to pi, right? So that means my interval for my solutions will be plus pi n. So whatever my solution is, it's going to be plus pi n. Okay, so let's work this out. All right, so where could we start? Let's get rid of this. 4 cotangent x minus 4 cotangent x will leave me with 3 cotangent x minus pi over 3, did I say pi over 3? Square root of 3 equals 0. So then I want to plus the square root of 3, leaving me with 3 cotangent x equals square root of 3 divided by 3, and then there's my answer. My answer is cotangent x equals square root of 3 over 3. And recall that cotangent is cosine x over sine x. So then I want to find the cosine that has square root in it. And as I look on my unit circle, again, that's cosine, right? Yeah, cosine with the square root of 3. Well, the problem is that it's cosine. So I actually want my y, because my y needs to have the square root of 3, because that's what's going to end up moving over. So let's see. I think pi over 3 is one that's going to work out for us. Let's see how that works out. Pi over 3 is 1/2 divided by square root of 3 over 2, right? So that'll be 1/2 times 2 over square root of 3. So that gives us 1 over square root of 3. And of course, square root of 3 in the denominator is a problem, so let's multiply by 1. So that gives us, right here, that's going to give us 3. And then over here, that's going to give us square root of 3. Perfect. Excellent. As you can see, that's a match. So we're game. This is it. That's our answer. What is our answer? Which one was it? Pi over 3. Pi over 3 is our answer, plus pi times n. And let's see, is there another one in the interval? Yes, there is. It's going to have to be, no, that's it. That's the only one. Because let's see, if I choose 2 pi over 3, let's see if that ends up working out for us. Let's see, cosine, see that negative sign on 1/2 already? already I know this isn't going to work because this negative sign here. This negative sign is going to make my overall answer negative square root of 3. But if you notice, where's it at? Where's my answer? My answer here, my answer which I found to be cotangent x equals square root of 3 over 3, there is no plus minus, it's only a plus. And here I have a negative. So that means this cannot work. 2 pi over 3 will not work. Only pi over 3 plus 2n. Okay, that does it. I hope this was helpful. Good luck in your studying.